Good morning all. In the previous video, we have seen about the introduction of the laser, their basic characteristics and the difference between the laser light and ordinary light. In the continuation of that, we are going towards the atomic transition, which is the basic process for the laser light emission. So we all know that all electronic transition occurs in atoms, which involves in fall of photons, which may be in your three categories. One of the categories induced absorption, and as far as emission is concerned, there are two categories. One is spontaneous emission and stimulated emission. We all know that if there is an absorption, it should be followed by emission. So in our cases, we are having two types of emission. One is spontaneous and other one is stimulated. Let us see one by one. So the first case is induced absorption. So it deals with the absorption process. For example, in the figure, there are two energy levels. One is E1, which is the ground energy level, and other one is E2, which is the upper energy level or excited energy level. So when you see the figure, it is clearly evident there is some input which is given to the atoms which is lies in the ground state. So as a result of that input, the atoms get some energy and it gets excited to the higher energy level E2. So that input may be called as a photon of energy, which is having energy HU, which is incident on the ground level atom. So as a result, atom in the ground state absorbs that energy of the incident photon, which gets excited, which as a result, it jumps to the higher energy state. So this can be called as an induced absorption. The difference in the energy levels E1 and E2 can be represented by the energy difference del E. So before absorption, there you are having some input that can be called as HF or HNU, which is the energy of incident photon, and after that, as a result of absorbing that energy, one atom goes to the excited state and you will be able to see that atom that sits comfortably in the upper energy level E2. As of emission is concerned, I have already mentioned that there are two emissions out there. One is spontaneous emission and other one is stimulated emission. So atoms in the excited state will not stay there for a long time. So it comes to the ground state after emitting a photon of energy E is equal to hnu. Such an emission takes place by one of the following methods. In spontaneous emission, atoms from the excited state returns to the ground state emitting a photon of energy which is equal to E is equal to hnu, which is occurring spontaneously without any external triggering. That means there is no external trigger happens during this emission. So this emission is also random and is independent of incident radiation. Whereas in stimulated emission, atoms returns to the excited state returns from the excited to the ground state by means of external triggering. So the trigger happens externally, that is one inducement of photon, thereby emitting a photon of energy which is equal to the energy of incident photon, which results in the two photons which is having the same energy, phase difference and of same direction of the incident photon. So this can be called as a stimulated emission, as the stimulation takes by means of external triggering in the excited state. So this is a schematic diagram of stimulated emission, which you know that there is some atoms in the excited state. You are giving some internal energy. As a result, it drops down. So you will be able to see the valence electron. So here the first figure represents the spontaneous absorption, the second figure represents the spontaneous emission, and third figure represents the stimulated emission. So here you can be able to see that the atoms, as a result of absorption, it goes to the higher energy level, and in case of spontaneous emission, the emission of photon happens spontaneously, which is random in direction, whereas in case of stimulated emission, one photon is stimulating the emission, which results in the two photons which are having same phase, same frequency and same directionality. So these are the difference between stimulated and spontaneous emission. So as we all see in the earlier slides, the atoms in the excited state induced to the return to the ground state, thereby resulting in two photons of same frequency and energy in stimulated emission, whereas in spontaneous emission, atoms in the excited state returns to the ground state, thereby emitting a photon without any external inducement. Emitted photons move in the same direction and are highly directional, whereas emitted photons moves in all directions and are random. Radiations are highly intense, monochromatic and coherent, which is the characteristic of laser in stimulated emission, whereas radiations is less intense and is incoherent. The photons are in phase and there is a constant phase difference in case of stimulated emission, whereas the emitted photons are not in phase. There is no phase relationship between them in case of spontaneous emission. So this is the principles of laser action. We all know that the stimulated emission contributes to our laser light as it results in the two photons which are having same frequency and same direction. So we are having some system which is having many number of atoms in the X-ray state. Now the photons are emitted by means of stimulated emission with the same frequency and energy, which is at the incident photon for the next level, which results in two photons of similar properties. These two photons further reduce the stimulated emissions of two more atoms in the X-ray state, resulting in 4 photon. These 4 photon induce 4 more atoms, give rise to 8 photons. Thus, by means of this multiplication, your photons count is increased and your intensity of the laser light is also increased due to the photons multiplication. So this is the principles of laser action, or these are the basic principles behind the laser action. So the multiplication of photons happening in the same phase and same frequency. Generally, the spontaneous emissions are more predominant in the optical region, but we know that the laser light is emitted by means of stimulated emission. To increase this number of coherent photons, stimulated emission must dominate the spontaneous emission. To achieve this condition, an artificial condition is proposed that can be called as a population inversion, which is necessary to achieve. So in the first figure, you will be able to see the normal population, whereas you are having more number of atoms in the ground state and only one atoms in the X-ray state. Whereas in population inversion, you are having only one atom in the ground state. Your population is completely inverse. That means more number of atoms are there in the X-ray state. So this is the condition of population inversion, which is the inverse condition of normal population. So that we are calling it as a population inversion. So this is the schematic diagram of population inversion and stimulated emission. So you are having more number of atoms in the X-ray state than the ground state. As a result of this, your photon count is getting increased here and there. You'll be able to see the number of photons moving here and there, which is getting increased. So these are the basic principles of laser action and the absorption and emission process that involves in the laser actions. Thank you.